The aim of this experiment is to create simulating files which executes various audio effects. Now the various things are here: the flanger audio effects, echo, distortion and reverberation. Now flanger is nothing but flanger is another form of echo. Like here the delay is not constant, here the delay will be varying. Now we will observe the flanger output for the original signal.
The discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform.
Now this is the time scope, like where you will observe the you can observe the peaks of the signal, and here it is the spectrum analyzer for the flanger signal. Now we will observe the flanger signal with reverberation. Reverberation is nothing but here reverberation is nothing but it is a form of where each delay sound wave arrives in such a short period of time that we don't perceive, like it is as a reflection, it is nothing but a copy of the original signal. Now we will observe the output of the flanger with reverberation.
The discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform.
You can observe that clearly. The previous one without reverberation and this one with reverberation, you can observe the change in the signal over here, and the spectrum analyzer is also changes, and you can observe the sound is not constant as compared to the flanger signal because it changes. Now we will observe the sound signal with respect to echo. Now we will see echo with reverberation. Now when you see echo with reverberation, echo is nothing but it is a delayed version of sound. Now when you observe between echo and reverberation,
the discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform.
See, you can observe the change in the peaks, like here you can observe a sharp value over here, and this is the spectrum analyzer of the echo with reverberation. Now we want to see with the distortion and with the now you see the distortion with reverberation. Now distortion is nothing but it creates a distortion with
the discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform.
Now, this is the reverberation, the output in time scope, and this is the spectrum analyzer. Now you can see in the distortion the signal is distorted. Now we have kept names called flanger, echo, distortion and reverberation. Now we basically see what is flanger actually. Now flanger is nothing but here we are taking a discrete sine wave and a constant. We are adding it and we are multiplying with gain, and that acts as one input and a constant signal as another input, give to the delay block. In delay block, that output from the delay block and the constant one we are adding. So this is basically the flanger block. Now after completing flanger block, now we go to echo block. In the echo block is nothing but the given signal is multiplied with the z⁻⁻2 with a delay and then pass through a gain of 0.5, and the same signal is added and observe that the output, this is the echo signal. Now we will observe the distortion signal. Now distortion signal is nothing but the saturation. Given one input and one output, you saturate. You kept as the upper limit and lower limit as 0.4 and -0.4. Now after audio effects, we go for reverberation. Reverberation is nothing but the given a input signal. Now that input signal from that output act as a feedback to the delay called z⁻⁻3 and gain. Now that both act as input and give as output. This is the reverberation. Now here we took a speech signal. It is the default. By the default we have this mp3 file, and here we kept samples per audio signal as 1000 here. And then this is just a manual switch used to select whether you want the flanger one or not. Here also the manual switch whether you want to select echo or distortion. Here the manual switch you want to see observe at the output. Now when you see here the time scope is basically used to see the output at peaks, here to listen the audio device, and here the spectrum analyzer. Now this is the so by this experiment, like we observed that the most modified version of the original audio signal, it is delayed, and then this delay is added to the original signal to give various audio effects. The way we cause delay or mix with other signal creates various effects basically. Now Now we observe that the various audio effects are implemented both in simulation and real time. This is helpful in understanding the various audio effects. The plain recorded signal can be modulated using various audio effects to make it much effective. Thank you.